Hey, Geo students, it's review day. Get excited for your test coming up. I am not going to do all of these. There will be a full answer key in our Google Classroom that you can take a look at, but I thought it might be nice to just walk through a few of them kind of in action so you could see like how they play out. So I'm going to jump ahead to number 5 so that you can see how one like that might break down. Now, it's a little bit tough to see, so I might just darken mine up here on the paper, but hopefully, even though it might have copied kind of light, hopefully you can still see it pretty well on your paper. All right. So you've got the triangle at the top, triangle ABC essentially, and then you have the triangle underneath, which is triangle, FED. All right, so that's what you should have. So as long as you can see it, that's good enough. All right. So when we look at this, I would definitely take a second, set up your statement, set up your reasons column, and then we will hop on into it. So since I've got my straight edge out anyways, I might as well make the most of it. So statements, reasons, I'll give myself some space here. Okay, so SR. So let's take a look. It's a good idea to plan ahead. So when we look at this particular one, let me slide over a little bit. We are trying to just prove that triangle ABC is congruent to triangle EFD. So nothing crazy, doesn't look like any corresponding parts, any of that kind of stuff. So you just have to start with what you have and see where you can go from there. So the very first thing we're given is that AD is congruent to CE, and that is given. So I can mark it in the picture. AD is congruent to CE. Now, if I take a look, that is not a pair of congruent sides in those triangles. It's part of this side from A to C and part of the side from E to D. So if I want to go from this little part to the whole thing and that little part to the whole thing, I can actually use that little overlapping segment of DC and do some addition postulate here. So even though there's no vocab word, I'm going to stop for a second because I can see something that I can do here. To be able to use addition postulate, I have to have 2 pairs of congruent segments first. So there's one pair. CD being congruent to itself will give me the second pair that I need. So I can get that into the proof using a little reflexive property. And then I can add those together. So right here, I've got it nicely lined up. AD plus CD should be the same as if we take CE and add it to CD. So that is our addition postulate. I want to rename it underneath, curly bracket or straight bracket. That part is completely up to you. But AD and CD together is going to give me the segment that starts at A and ends at C. So AC there. And then CE and CD fully will give us E to D, or D to E. It doesn't really matter because it's the same segment either way. That gives me a pair of sides in my triangles. All right. From here, I'm going to go back to my givens. We are told that AB is parallel to EF. And so this is parallel to that. Keep in mind, parallel does not mean congruent. It literally means that I should have pairs of angles that I can get from those parallel lines. So I'm going to grab my highlighter and just highlight those 2 lines. So I've got this line here parallel to this line here. And if I connect, you can kind of see that like Z shape pop out. It's those alternate interior angles right there that I want to get from that statement. So this is angle A, that's angle E. You could always put numbers in there, but since I can label it just off of that one angle, I'm going to make life a little easy there and say angle A is congruent to angle E. But down here, don't forget, if here's my vocab term, then that comes right down here and you keep rolling with it. So parallel lines implies that we should have congruent alternate interior angles. And there we go. That's a pair of angles in my big triangles here. So I've got side down, I've got an angle down. And if we take a look at that last given, they just kind of hand you one for free, which is nice. So you could go back and add it to one of the earlier givens, Or why not? I'll just keep going. I'll make my next step. AB is congruent to EF. So this congruent to this. So keep in mind, it being congruent had nothing to do with it being parallel. Two different things here. But that does give us a third statement we can use towards congruent triangles. So in the diagram, especially when they kind of connect like this, it really helps to cover one of them up. So if I cover this up in this triangle here, I have that side, this angle, and we were able to put that side together. So we have side, angle, side right here to prove those triangles congruent. So side, angle, side will prove triangle ABC congruent to triangle EFD. And we're done. All right. The other proof that I thought might be nice to look at together, because it has some different steps with it, is actually the very next one, number 6. So the two things that stand out to me in this particular proof are the fact that you're not proving triangles congruent. So we have something beyond congruent triangles going on here. You also have a given that we don't see all the time, and that is the given of FG is an altitude. So I thought it might be nice to do this one together as some review. So statements, reasons. All right. Now the fact that we're going to try to prove angle A down here congruent to angle E, that means our goal step, and we can maybe even squeeze it in right here, that should be that we want congruent triangles first. So I would say that we would want triangle AFG congruent to triangle EFG. And then if we can get those triangles, then we can go right on to getting those angles there. All right. FG is an altitude of triangle AFE. Whew, that's a lot. Given. You might need to go back to your reason sheet to remember this one. Altitude, that's our vocab word. So that's what we're going to latch on to here. We're going to bring it right down here. So an altitude implies, if you can think, altitude's another word for the height. So altitude implies that you have perpendicular lines. So in the picture, if FG is the altitude, that means that FG is perpendicular to AE. And then what does perpendicular give? Well, take that vocab term right there. So I'm going to keep on rolling with it. It'd be more fun if I had different color highlighters, but I only have a yellow one sitting next to me. So perpendicular is going to give me right angles. I'm going to take advantage of just numbering those angles to make it easy to talk about. So I'm going to say angle 1 and angle 2 are right angles because perpendicular gives us right angles. All right. From right angles, you know that there's multiple things that could be said. Right angles, if I bring that right down here, can give me right triangles, or it can give me congruent angles. So we're going to have to wait and see. Because I only have so much space, rather than putting both steps in, I'm just going to wait, see what happens here. All right. Let's see, what else do we have to work with? We have step 5, that G is the midpoint of AE. And so if G is the midpoint of AE, well, because it's given, then I'm going to get some congruent segments here. So step 6, I'm going to get that AG, I had it right small here, is congruent to GE. If you find yourself running out of room, just grab another piece of paper. Not a big deal. And that's because midpoint implies 2 congruent segments. And if you like highlighting the vocab words, keep rolling with it. So midpoint, and then midpoint came right down here. All right, that finally gives us a pair of sides in the triangles. If we stop at this point, we don't have any other givens to work with. So when you look at the diagram, we're either looking for that X shape for vertical angles or for side by side. And that's what we have here. We have side by side, so we have a little overlap. So I can make step 7, that FG is congruent to FG, which will give me a pair of sides, and that's going to be by reflexive property. All right, so take a look at what we have. When we come back up here, I'm going to cover up one triangle. Oops, I got a little scribble on there, but that's okay. And if I focus, I have the side here, I've got the side there, and if I can make this a pair of congruent angles, this is side, angle, side. It's not hypotenuse leg because I don't know anything about the hypotenuse over here. So that means that back in step 4 for me, I want to say that right angles implies that we have congruent angles. And I'm just going to say that angle 1 is congruent to angle 2 so that it'll give me a pair of angles right there. All right, I've got 2 last steps to go. I think I can sneak them in here. Once I have side angle side here and side angle side there, that's enough to hit my goal step. I can now say that triangle AFG is congruent to triangle EFG, and that's by side angle side, congruent to side angle side. So then I can finish up with angle A is congruent to angle E, and that is that final little step of corresponding parts of congruent triangles are congruent. Or you can write it as congruent triangles implies corresponding parts congruent, but I'll put it down here, CPCTC. Right? So there's nothing wrong with using CPCTC as long as you know what the heck it stands for. Okay, so there's definitely more proofs to look at. Hopefully that got you through some of the tough ones to give you a little head start. And make sure, fill out that post-video question so that I know which ones or which concepts we might need to go over together in class. Thanks for watching.